Hello and welcome to the 100 subscriber special. What we're going to do today is we're going to make a 3D cube in any kind of graphics library that you can use to draw lines with. So I'm going to be using a header file that I made called gpanel. You don't have to use that if you don't want to. You can use any software that can draw lines. You can use any library that can draw lines. So what I'm gonna do is I'm just gonna use gpanel. So include gpanel here .h, and we're also gonna need to include vector, and that's just gonna be to hold some of the it's just gonna be a way to make an easy array that can be resized flexibly, so that it's like a dynamic array basically. But anyway, first what we need to do is we need to make sure that you need to go to here and go to properties and make sure that we need to make sure that it's on subsystem Windows. That way, so that we can do the win main instead of just regular main. So first we're gonna do int win API win main. Then we're gonna do h instance previous instance. This stuff is just for this is just for like the window. It's just so that we don't have to have a console window open. But anyway, let's do command line and then int command show, and there we go. Okay, so now what we need to do is we need to make well, first let's return 0 because we can't forget to return 0. But anyway, now what we need to do is we just need to make a subclass that inherits from gpanel. So we need to do class panel, we'll just call it panel, and we're going to do public gpanel. And then now what we do is we go and we make panel. We're just going to make a class from the panel class we just made. And then now we go here and we do panel open window, and we do 200 by 200, and each pixel will be 2 pixels by 2 pixels. And there we go. And now we've got a window. If we were to run this right now, it would just, what it would do is it would just make a window here. As you can see, it made a window. So that's all. That's really all that this is all for. It's really just so that we can get a window that can make graphics. So anyway, now the first thing we need to do when we're making 3D graphics is we need to make a struct called vector3, and this will just hold a vector. This is just going to hold a vector value, values of x, y, and z. And basically, the way this works is it's just x is forward and backward, y is up and down, and z is left and right. So it's basically like the directions of three-dimensional dimensions. Yeah. But anyway, now we do struct triangle, and inside that we put vector3, and then we do an array of 3 points. Three vector 3 points, and that's because a triangle is just it can be defined by 3 points, because each triangle has 3 points. So we can have 3 points in different places in the space. So yeah, but we also need something that will hold the triangles and like kind of group them into like a model sort of. And to do that, we'll make a mesh, struct mesh. And now what we do is we do standard vector triangle, and we call this trees. Basically, this is just a group of triangles, and it can be flexibly changed in size because it's using a vector. That's what the vector's for, really. I think that's probably going to be like the only thing we use vectors for in this like preview. But anyway, now we've done the mesh, and now what we need to do is we need to go down here, and we need to do void heartbeat override, and let me put the parentheses here. Basically, this just what this does is it just runs every time that the screen refreshes. We also need to do void created override. Basically, that just runs once whenever you open the window. So anyway, every time that the screen refreshes, we need to fill it to 0. We need to fill the screen to black. The 0 is just black. Okay, so now what we need to do is we need to go up here and we need to make private space, and we do, okay, let's also put public here just so I don't forget. But for here, right here, we do mesh cube. We're gonna make a mesh called cube. And now we go down to heartbeat, and what we're gonna do is we are going to make a loop that iterates through all the children of the array that holds the triangles. So we go auto try cube dot trees, and that will make a variable called try, and it will equal to whichever one that's on, and whichever one it's currently iterating through for each one, if you know what I mean. But anyway, so now what we do is we need to go up and go into excuse me. We need to go into created, and what we need to do is we need to actually give this cube points. We need to give it all the points of the triangles. So we're just going to put parentheses here, and I already have it written down in a notepad right here so that it doesn't take forever to make them all. So we just put this here, and let's indent it correctly. And there we go. Now that we've done that, what we need to do next is we need to make a struct called matrix 4x4. And basically the reason why we need a matrix 4x4, a 4x4 matrix in other words, is so that we can easily project the triangles onto the screen, so that they're not just 3D data anymore. We need to actually we need to actually convert them to the position on the screen in 2D space instead of having it be 3D space, if you know what I mean. So for a matrix, what we need to do is float m4 equals, let's just do 0. We'll initialize it to 0. Alright. So now, what we need to do is we need to go down to where we made our cube, and we need to do matrix 4x4 projection matrix. There we go. So now, now that we've made our projection matrix, we need to actually you know, like, populate it. We need to actually put the stuff. We need to actually put like the math and stuff into it so that it is actually usable. So what we need to do is we need to go and we need to define all the mathematical all the mathematical components that we were going to put into our projection matrix. So let's put a variable called z near, and basically this is just gonna this is what this is gonna do. This is just describing the point where, or the closest that it can be. So we're gonna put 0.1, and now for z far, we're gonna put 1000 0. Okay, and now we need a field of view. So we need to do FOV, and let's do 90. Let's do a field of view of 90 degrees. Okay, and now we need to do aspect ratio. Aspect ratio equals, this will be the screen height divided by the screen width. So we do float screen height divided by float screen width. There we go. And now what we need to do is we need to make one called FOV rad. FOV rad. And this is just gonna, what this is just doing is it's converting it from degrees into radians. So we do 1 divided by tan f FOV 0.5 f divided by 180 0. Okay, and then we do times pi. So 3.14159 f, and we're done with the FOV rad. So now what we need to do is we need to actually put these into the projection matrix that we made. So we do projection matrix column, or row 1 column 1 equals aspect ratio times FOV rad. Oh wait, I accidentally forgot to put M. There we go. Alright, so now we do projection matrix row 2 column 2 equals FOV rad. Now we do projection matrix M2 2, or in other words row 3 column 3, and we do equals z far divided by parentheses z far minus z near. Okay, and now we do projection matrix row 4 column 3 equals parentheses negative z far times z near divided by well, close parentheses, divided by z far minus z near. Okay, so now we do projection matrix row 3 column 4, and that will equal 1, and then projection matrix row 4 column 4, we do 0. There we go. Alright, so now we need to actually make a function to multiply these to actually multiply these this matrix with our vectors. So we need to go up here and do we need to make a new function, vector3 multiply matrix Victor, and then we'll do vector3 in, and then matrix 4x4 m. There we go. Okay, and we're gonna make it. We're gonna make a vector3 called out, and we're gonna return it after, so that we can actually get back a product of our multiplication. And I don't think it's called product, but I forgot friggin' mathematical terms, to be honest. But anyway, so first of all, what we need to do is out.x equals in x times matrix row 1 column 1 plus in y times matrix row 2 column 1. Then we do plus in z times matrix row 3 column 1. Then we do matrix row 4 column 1. And now that we've done that, we can just copy this whole thing, and for y we'll just do the same thing, except instead of it being column 1, we'll do column 2 on each one. Oh wait, I accidentally put the wrong one here. Okay, so there we go. Now we put column 1. Alright, we've done that one. Now we just do the same thing for z as well. And then we do column 3, column 3, column 3, and column 3. But now we need to make a fourth variable. We need to do float w. And we're going to make this equal the fourth column. The fourth columns. Oh wait, I put 4 instead of 3. Sorry. Okay, let's put 3. There we go. Okay, so now we need to normalize it. So we need to do if w does not equal 0, and this is just so that it doesn't mess up the program if it ends up being 0, because 0 numbers divided by 0 are of course 0. So that will mess it up if we let it run loose. So let's just do out.x divided by w, out.y divided by w, and out.z divided by w. And there we go, that's done. So now what we need to do is we need to go down and we need to make a triangle in here called triangle projected tri. And now what we need to do is we're gonna actually have to make a function that can draw triangles, because we already have one that draws lines, but we don't have one that specifically draws triangles. So let's actually make one real quick. Let's do void draw triangle, and we're gonna do vector3 0, and then vector 3.1, vector 3.2, 0.2, and then we'll do the color FC. Okay. So now what we're gonna do is we're gonna do we're gonna use the function that draws lines that I have in gPanel. You can use whatever function your library uses if you want to do this, but mine is just draw a line, and then we do 0.0 x 0.0 y, and then that's the first point done. So then we do 0.1 x and 0.1 y because it's drawing from 0 to 0.1, and then we do C for the color. And now we just copy this, do it 3 more times, or 2 more times is what I meant to say, and we do 1 to 2, and for here we do 2 to 0, and that will draw, like, it'll kind of bound the triangle. It'll go from each point and draw a line to on the points of the triangle to each one. So anyway, now that we've done that, what we need to do is we need to go and actually draw the triangle whenever we need to actually draw the triangle. So first of all, actually, let's do projected try P. We need to actually multiply the vectors of this projected try with the matrix. So we're going to do P0 equals multiply matrix vector, and we're going to do try P0, and then we're going to do projection matrix, the one we made up here earlier, right here. So then we're going to do the same for all of them. So we're going to do 1, and we're going to do 2. There we go. Alright. So now that we've done that, we can actually draw triangle projection, or projected try P0, and then we're going to do the same for all of them. 1. Wait a minute. Let me see. Let me see. What is going on here? Identifier draw. Oh, wait. I put triangle. What the hell is a triangle? my bad. I put triangle by accident. But anyway, let's see. Let's put 2. And then we're just gonna make it white. So let's do 255. Move that over by 16 bits. We're gonna need to do. Wait, we're gonna do 255. Move that over by 8 bits. And then we're going to do 255 and just leave it there because that's where the blue space is. So there we go. Now, if we run this right now, it's just going to, what it's going to do is it's just going to make a little pixel at the top right corner. So what we need to do is we need to actually kind of offset the, the points onto the screen and, like, make it fit. So first of all, what we need to do is we need to go over here and make some space. Let's do projected try dot P0 dot X plus equals 1. And we're just going to do the same thing for y. And now we're going to copy this and do it for each point. There we go. So we're going to offset these by 1. And now what we need to do is we need to do projected try dot p dot and we're going to do 0 dot x times equals 0.5 times float the screen width. There we go. And now for y, what we're going to do is we're going to do the same thing, except we're going to do screen height. And now we just copy this and we do it for each member of the triangle. We do it for each point. There we go. So now if we run this, we should see a box. Yeah, we see a box here, but it's kind of like, this just looks like an X, so we gotta actually push it further into the screen. So let's see. What we need to do is we need to make a new triangle called transtri, and we put it up here. So let's just let's do transtri. There we go. Make transtri, and let's replace triangle, or let's replace try with transtri. And what we got to do to transtri is we're going to make transtri equals try. And what we're going to do is for each point of transtri, P0, we're going to add 3 to the z component. So 0f, there we go. And now we do the same for the second point and the third point. There we go. Now if we run this, we will see a cube. As you can see, it's no longer just an X, it's actually a cube. But this is kind of just static and it's just sitting there. So, I think we should probably actually, we should make some controls to actually turn this thing so that you can actually see the 3D aspect of it. So what we're going to do is, first we're going to actually, what we're going to do is, we need to go and make, let's see, what we need to do is we need to go and add up here, we need to add 2 new variables called xvar and zvar, and these are going to be used to help save the rotation position whenever you press the keys on your keyboard. So let's go down back to where we were. And first what we need to add is, let's see, we need to add, let's add if keys W zvar plus equals 0.1f. And we're going to do the same thing for each key. We're going to do S, and we're going to subtract 0.1. Actually, you know what, let's do 0.01 instead. That way it's slower. Okay, and then we're going to do D. And for D, we're going to do xvar. and we're going to do plus. And then we're going to do the same thing for A. We're going to have x var, and then it's going to subtract. There we go. So now we need to actually make these new these rotations. So what we need to do is we need to make we need to make two new matrices, and they're going to be called X rotation and Z rotation. So let's do matrix 4 by 4 Z rot X rot. And then, okay, what we're going to do is we're going to do Z rot M row 1 column 1 equals cos F Z var, and it's as you can see, it's going to use the rotation variables that we've set up there, and so that way it'll actually be affected by the mouse, or not the mouse. It'll be affected by the keys you press, if you know what I mean. So let's do Z rot M 0 1 equals sine F Z var, and there we go. Now we do Z rot M 1 0 equals negative sine F Z var. Oh wait, I accidentally put curly brackets. Okay, Z var. There we go. Now we do Z rotation M column or row 2 column 2 equals cos F Z var, and then we do Z rotation M2 2 equals 1, and we do the same for Z rot M3 3 equals 1. Okay, there we go. So now we got to make the X rotation. So let's do X rot M row 1 column 1 equals 1. Then we do Z rot M row 2 column 2 equals cos F X var. And we do X rotation M1, M2, or yeah, you know what I mean. As sine F X var. Then we do X rot rotation M2 1 negative sine F X var. There we go. And then we do X rotation M2 2 equals cos F X var, and X rotation M3 3 equals 1. There we go. So now that we've made those two, which was a pretty slow process, but now we're done, thankfully. So let's see. Okay, so what we're going to need to do now is actually to make two new triangles called X rot tri and ZX rot tri. So now what we do is right here, we will put right here in this in place of the try, we're going to put ZX rot try, or wait, rot try. There we go. And now right here we put X rot try dot P0 equals multiply matrix vector try P0, and then we're going to do X rotation, which is the matrix we made up here. So then we're going to copy this, and we're going to do it 2 more times for each of the points. There we go. And now we gotta do this again, but this time we're gonna do ZX rotation equals rotate X rotation, and we're gonna do that for these two, and instead of X rotation we're gonna have Z rotation. Now let's see what this does. And there you go. As you can see, now we can actually turn a cube, which is nice. So now we have a cube that we can turn around with the buttons on our keyboard, which is pretty cool. Now, okay, I hope you enjoyed this video. I'm so thankful for 100 subscribers. Thank you guys so much for 100 subscribers. I didn't think that we were gonna get there, but we did. I hope you enjoyed this 100 subscriber special, and yeah, that's it. So yeah, goodbye.